Hey everyone, we are going to take our class notes, first day of class notes on 11.3, where we are working with logarithmic functions. I would probably say we're going to be more working with the equations today than the functions. We will eventually graph them, but we're going to do some solving of log equations and learning how to switch forms as well. So what's a log? It's the inverse of exponential, but also a log problem, you'll actually see the log within your problem. So this is what a log equation looks like. Y equals log base a of x. So that's what this says, the logarithm of x to the base a. That's another way to say it. I'll usually just say log base a of x. Log base a of x. Then it shows you, which means the same thing as this. So you're seeing that we can write all logs as exponential. What does it say about the logarithm? A can't equal 1. So your base can't be 1. And all positive numbers for x. X has to be positive. So if you see that this is a 1 or that this is a negative number, then you know that there's going to be no solution over here. And the meaning of log, as you're going to see next, it says that a log is an exponent. Log is, so equals an exponent. And I think that'll be important for the way I like to look at the form. And it goes on to say the rest of that. Then there's these special properties, which says if your base and your value are the same, then your exponent equals 1. And I can say that this is the exponent because what did we just say? A log is an exponent. So this log equals the exponent of 1. When the base and the value are the same, these are the same number or same letter, the entire log becomes a 1. And this one is saying if your value, doesn't matter the base, so I don't want to talk about the base, doesn't matter what that is, but if the value is 1, if you see a 1 in this location with any other number here, the entire log becomes a 0. So these are shortcuts that we can use. They're special properties. So when we start to look at the notes and start the examples, I kind of put these off to the side. These are the special properties. You probably want to do that on homework as well, just to get used to using these and seeing these. If these are the same, the entire log becomes a 1. If this is a 1 and this is any other number, the entire log becomes a 0. And then you don't even have to switch forms for those. One thing I want to stress is, yes, in the notes it says this, and in the book it'll say this. But I like to think of this as whatever is here is the exponent. Whatever is here is your base. And whatever is here is the value. So if I want to write this in exponential, we know that an exponential is base raised to the exponent equals a value. So value, base, and exponent. I think this piece is pretty clear because we've worked with exponentials for some time now. Not just the 2 days that we did 11.2, but in Algebra 1, in chemistry, we've seen things, even in math, in this year, we've seen things being raised to a power. We know that this is the base, we know that this is the power or exponent, and we know that that will equal some number, which we can call the value. So if we know these three things, then when I say this is the exponent, whatever's up here is going to go there. When we say that this is the base, whatever's here is going to go there. So that's why those are both A, that's why those are Y. And then when we say value, X is the value here, and we consider it the value here. So I kind of think of it as logs. Exponent equals log to the base and value. And so then exponentially, when I'm thinking about this, I think of this as value. And actually, I'm going to actually write it this way. I think I prefer this. Base exponent equals a value. So that makes it easy because the next thing is just rewriting it as a log. And you could write off to the side, what's the base, what's the exponent, what's the value. So when I go to write my log, I need to write this as a log. So I need to write it like this. So what's the exponent is a -2. After exponent is log, L-O-G. Then the base here's my base, exponentially, this is the base, and maybe I should write that in. Base, exponent, value. So 10 is my base, and then this, exponentially, base, exponent equals a value. So my log, the next thing I need is the value we find here. So when it's exponentially, it's just about knowing, and I'm fine with saying log base 10 of 0.01 equals -2. You can write it the other way as well. So I'm going to do that this time. Log to the base 16, right? This is the base, exponent, and this is the value. I want to write it this way, log base, next I need the value, so base value equals, a log equals an exponent, so my exponent is 1/2. So this is how we write it as a log. And I switched up the order, hopefully that does not throw you off. Okay, next we're going to write these as exponentials. So 2 is the base, 128 is the value, and all logs, this is a log, which equals a exponent. So when I go to write this exponentially, it's base power equals a value. So 2 power exponent equals a value. On your power sheet, you should see that that's correct. So we take this number, we raise it to this power, and it should equal this piece that's here. This is all you need to show for this example. Switching from log form. Now, one thing I haven't stressed is similar to square roots. A square root has an index of 2, and we just leave it off because it's most common. Logs, the common base for log is 10. So when you don't see a base, you need to know that there is a 10 there. Common base is 10. You might want to write that down. Now, this is the base. This is the value. Log to the base of the value equals an exponent. So just getting used to saying that because logs are new for most of us. Base is 10, exponent's -4, and the value would then be 0.0001. We just switched from log form to exponential, and I think that's important for the solving piece because yesterday we just solved exponential. So if we can switch forms, maybe use our base sheet again to try to write them with the same base or solve the equation that we have. So again, this is log to the base 9 of 27, which is the value, equals the exponent. So when I switch forms, I have 9 is the base, x is the exponent, and 27 is the value. And this is an exponential equation. We have a variable here. So this is why I'm saying base sheet's going to be important. I can write 9 and 27 with base 3. 3 squared and 3 cubed. And then I can use the property we learned yesterday, 2x equals 3. Divide the 2 to get x equals 3/2. Keeping in mind these being the same or this being a 1, thinking through that, I didn't see that here. I'm not seeing that here, so I'm going to go ahead and switch forms. Log to the base of the value equals the exponent. So to write it exponentially, this is the base, this is the exponent, and this is the value. Base, exponent, value. Now when I switch forms, I don't have an exponential equation because there's no variable here, but I have a quadratic equation. And I know that I can solve quadratics. One of the ways is using square root method. So I'm going to root both sides and get x equals plus or minus 2. But the base we learned cannot be negative. So we have to exclude that and just say x is 2. We do not want to include negative. No negative bases is what the direction said before, or the property rules said. This stands out to me because I see a 1 here and any other number here. I could switch forms, But I could also just look here and say, okay, the shortcut is if this is a 1, this entire log becomes 0. So this would be a 0. X equals 0. Feel free to switch forms if you'd like. You'd get 4 to the x equals 1. Anything to the 0 power becomes a 1. So you should then know and be able to solve it that way as well. And if I have a 1 here, special property says if you have a 1 here, then the base and the value have to be the same. So I don't have to switch forms to see that x is going to equal 5, right? In order for us to have a 1 here, these would have to be the same. Could you switch forms and get to the same thing? Sure. This is the base, this is the exponent, this is the value. Base, exponent, value. X to the first equals 5. That means x equals 5. All right, that's it for today. Hope that's clear. Let me know if you need some help. Bye, everyone.